A 7 billion parameter AI model is 14 gigabytes. Your laptop has 8 gigs of RAM. Game over, right? Not if you know about quantization. Welcome to Tech Decoded by Soft. I'm Alex, and today we're breaking down quantization, the technique that makes massive AI models run on ordinary hardware. By the end of this video, you'll understand exactly how it works, which formats to choose, and how to get started in 30 seconds. Let's start with the problem. Every AI model stores its knowledge as numbers, billions of them. By default, each number uses 16 bits of precision, called FP16, so a 7 billion parameter model needs 7 billion times 2 bytes, which equals 14 gigabytes. A 13 billion parameter model, 26 gigabytes, and a 70 billion parameter model, 140 gigabytes. Most laptops can't even load a 13 billion parameter model, let alone run it. Quantization solves this by reducing the precision of those numbers. Instead of 16 bits per number, you use 8, 4, or even 2 bits. At 4-bit quantization, that 14 gigabyte model shrinks to just 3, 5 gigabytes. That's a 4x reduction. And here's the surprising part: the quality barely changes. On standard benchmarks, a Q4 quantized model scores about 2% lower than full precision. For everyday use, you can't tell the difference. Think of it like JPEG compression for photos. A raw photo might be 25 megabytes. A JPEG version is 2 megabytes. Can you tell the difference? Usually not. You lose some microscopic detail, but the image looks the same. Quantization does the same thing for AI. The model loses some numerical precision, but its answers are virtually identical. Now, there are 3 main quantization formats you need to know about. Let me break down each one. First, GGUF. This is the most popular format for running AI locally. It's what Ollama and LM Studio use. GGUF runs on CPU, GPU, or both. It's a single file that contains everything, and it works on Mac, Linux, Windows, even a Raspberry Pi. When you see a model named something like llama.cpp, 27BQ4KM.GGUF, that Q4 tells you it's 4-bit quantized, and KM means it's the medium quality variant. Q4KM is the sweet spot for most people. Second, GPTQ. This format is optimized specifically for GPU inference. It's the go-to for production, serving with frameworks like VLLM. GPTQ gives you the best throughput when you're serving models to many users simultaneously. The downside? It's GPU only, so no CPU fallback. Third, AWK, which stands for Activation-Aware Weight Quantization. This is the quality champion. AWQ's key insight is that not all weights are equally important. It identifies the critical weights that have the most impact on output quality and preserves them more carefully. The result? 1 to 3% better quality than GPTQ at the same bit width. If quality matters most, AWQ is your pick. And there's a new frontier. EXL3, from the Llama v3 project, can compress models down to just 6 bits per weight. That means a 70 billion parameter model fits in under 16 gigabytes of RAM. And Microsoft's BitNet trains models using only 3 values, -1, 0, and +1. A 100 billion parameter BitNet model can theoretically run on a single CPU. We're entering an era where the question isn't whether a model fits on your device, but how aggressively you can compress it. So which format should you choose? Here's the simple framework. If you're running locally on a Mac or laptop, use GGUF Q4KM with Ollama. If you're serving on GPUs in production and need maximum throughput, use GPTQ. If you're serving on GPUs and quality matters most, use AWK. For 90% of developers, the answer is GGUF with Ollama. Start there. Getting started takes literally 30 seconds. Install Ollama, then run Ollama run llama.3. 2. That's it. Ollama automatically downloads the Q4KM quantized version. You're running a 7 billion parameter model locally, no cloud, no API key, no cost per token. Want more control? Use llama.cpp to quantize any model yourself. Download a full precision model from Hugging Face, run the quantize command, and you have a lean, local-ready model in minutes. One important caveat: quantization isn't always the answer. For research and benchmarking, use full precision. For fine-tuning, train in full precision, then quantize the final model. And for extremely sensitive tasks like medical diagnosis or financial modeling, where every decimal matters, think carefully before quantizing. Quantization is why the Run AI locally revolution is happening. Without it, you'd need server-grade hardware. With it, a $999 MacBook Air becomes a capable AI workstation. The technology is mature, the tools are user-friendly, and the quality trade-off is negligible for 95% of use cases. If you're not running local AI yet, quantization just removed your last excuse. If you found this helpful, hit subscribe and the notification bell. We post new AI tutorials every week. Check the description for links to our full written guide on quantization formats. Next video, we're covering speculative decoding, the technique that makes models 2 to 3 times faster without any quality loss. See you there.